Hi, so this is going to be a video about the lab simulation of ocean surface currents. So a simulation is a model, and it's not the real thing. So what we do is going to be representative of things that happen in the real world. So it's not the actual stuff, it's a simulation is something that acts like it. Okay? All right, so lab simulation of ocean surface currents. Our focus question is what causes ocean surface currents? What factors other than wind influence ocean surface currents? And what do ocean circulation patterns affect? So you may have some ideas on what these answers are now. You might not have any ideas. Hopefully by the end of this lab, you can answer those three focus questions. All right, so before we begin, I need you to take a few minutes and read through the text. This is the background information. Read through it, highlight what you need to, take notes on what you need to, write in the margins or annotate. You are responsible for knowing this information for the test. There is no textbook. This is the textbook. So if you would, pause here and make sure you take a couple minutes to read through, highlight, annotate, write notes. So pause. All right, so we're going to start in on the lab. So you should have, or you should see a photo in a minute, a shallow pan, objects such as rocks that represent the land masses, some pepper, flexible neck straws, extra towels for spills, paper pencil for sketching currents. So we're going to perform the experiment, and it's your job to pause it when you need to make sure that you accomplish some things. So it says obtain materials, a shallow pan, pepper, rocks, and straws. You're going to fill the shallow pan about half full of water. You're going to sprinkle the pepper on the water, not all of it. And from opposite corners of the pan, you're going to use a straw to gently blow across the water's surface. The lower section of the straw should be close to the water. Determine which straw position will best simulate a current of moving pepper. So we're going to demonstrate with a video how to do this lab, and we're actually going to do the lab and record it. And it's important to know that when the wind blows across the ocean, it actually doesn't blow into the water, it blows across the surface of the water. So for this simulation, we need to figure out how to use the straw and the air in our mouth to blow across the surface of the water and not into the water. Then number 4, you're going to sketch the path of pepper as the wind blew, and you're going to label your drawing. So in this blank area, you're going to draw it, and you're going to label it. Place a rock or similar object in the water so that it is only partially submerged. And before blowing through the straws, make predictions about what effect this landmass will have on the current of the pepper. So stop the video now, pause now, and create your prediction. All right, now that your prediction has been made, you're going to blow through the straws from the same direction as before and observe the currents of the moving pepper. I'm going to assume that it's going to be slightly different, but there might be some similarities. You're going to sketch the path of the pepper as it encounters the landmass and label your drawing. So you're just going to have a sketch here, and it's going to be labeled. You're going to add another partially submerged object or rock and repeat the procedure above. I need you to predict and pause the video. And then we're going to have the participants blow through the straws, and then you're going to sketch what you see, and you're going to label your drawing. Using a copy of the Global Wind Patterns sheet on page 4, draw in the continents and predict the direction of flow for major ocean currents in the Pacific Ocean. So we're going to go to that paper, which is right here. So this is what the winds actually do on our globe. And what you need to do is you need to sketch in a continent in the northern hemisphere and a continent in the southern hemisphere. So I tend to sketch in North America and then connect it with South America using Central America. And it doesn't have to be perfect. So you're going to have a continent up here and a continent down here. Now, based on these wind patterns, you should be able to predict the currents, the water currents pattern. Think about what we just did. When we blow the air through the straw, did the pepper move in the same direction as the wind, or did it move on opposite directions? And when it encountered a rock or landmass, did it plow through the rock, or did it go around it? And how did it go around it? That's what you need to do here. So you're drawing your continents, and then with a colored ink or marker, something that I can see, you're going to draw in the water movement, the ocean currents. Okay? So that's what you're going to do for number 10. Once you've completed that, then you're going to actually look at your predictions and see if they're right. So you're now going to go to this map and see if you drew North America and South America. Did you draw currents that looked like these? Did you draw currents that looked like these? How about the Gulf Stream? And how about the Brazil currents? Did you draw anything that looked like that, or was it totally different? Okay. All right, so that is the first page of the lab sheet. Now we're done with the lab, so we're going to put all the materials away, and your job is to answer the analysis using complete sentences. So what I will do is I will embed the video of the lab wherever I can and however I can get it embedded. So your job is to complete 3A using complete sentences.